Hello, everybody, and welcome back. It's been a while for me. Maybe it's been a while for you. But today we're starting our last unit of pre-cal, independence, and probability rules. So let's get cooking talking about probability. So before talking about these, let's just talk about the general idea of probability. So probability is the long-term likelihood of an event after a large number of repeated trials. Basically, something like flipping a coin. You wouldn't think the first time you flip a coin, you get heads and, oh, there's a 100% chance you get heads. What it means is the long run number of trials. So if I were to flip a coin millions and millions of times, I would expect about half the time I'd get heads and about half the time I'd get tails. So to calculate a probability, what we do is we're going to take the event, and the event is what we're trying to see if it actually occurs, and then the sample space. Sample space is the combination of all possible outcomes, and it doesn't say it here, but it's assuming that each outcome is equally likely. So if each outcome is equally likely, I just do the number of the time event can occur divided by the number of possible outcomes in a sample space, and that'll give me my probability. So we're going to take a look at this example. We're going to do this example in class, but I want you to go ahead and look at this and see if you can take this event, which the event here is the day of the week containing the letter U, and try and calculate its probability. So now we've talked a little bit about how to understand events. Sample spaces, we're going to talk about what it means for things to be independent. So basically the technical definition of independence is knowing the outcome of one event will not help predict the outcome of another event. So if you can't predict the outcome of another knowing one, then the events are said to be independent. So another way to say it is independent events don't affect each other. So one event happening does not affect the likelihood that another event happens. So for example, if I roll the number 6 on a 6-sided dice on the first roll, then the number rolled on, I realized just here that this is a typo. So the number rolled on the second roll, so the number rolled on the first roll, number rolled on the second roll are independent events because the dice doesn't remember what you just rolled and it doesn't try to roll something different. Height and foot size would not be considered independent because generally, if you're taller, you tend to have larger feet. So we're going to do this in class, but I mean, you can go ahead and take a second to look at this, try and figure out if these events are independent or not independent. So I like the fifth one. Fifth one's my favorite. You can try and figure out if that's independent. So mutually exclusive is different from independent. So if two events are mutually exclusive, it means that they cannot occur simultaneously, which means that they cannot be independent. So I'm going to let you think about why that means they can't be independent. But if two events are mutually exclusive, they cannot occur simultaneously. Things like it being dark outside and it being light outside. Those things can't both occur simultaneously. So what I'm going to let you do is I want you to try and figure out which of these events would be considered mutually exclusive. All right, number 3, be careful with that one. That one's kind of tough, but I'll let you think about that one. So, all right, probability notation. So this is just a little bit of notation. So when you see these things, you'll understand what these are saying. So the probability of event A, so just event A happening, is written P of A. So you read this as probability of A or P of A. It means the probability that event A happens. We talked about how to calculate that simple probability. So the probability of event A and event B happening means that both events occur at the same time. So if you see this symbol right here, it says P of A and B, or P, this is called the intersection symbol. It means both A and B happening simultaneously. That means probability of A and B. And what that means is both events happen at the same time. So probability of event A or event B means, not means that either event A occurs, event B occurs, or both occur simultaneously. So be careful with A or B. This last part right here, event A and event B occur simultaneously, is important to remember. One way to think about this, both of these, if you have a Venn diagram, so P of A or B means everything inside of both circles. So everything here, here, and here, this would be P of A or B. But probability of A and B, so if I were to draw another little Venn diagram, probability of A and B, this only happens in this little part right here. And we'll do a couple examples where we draw a Venn diagram to help calculate some of these probabilities. So the last one is called conditional probability. It's the probability of event A given event B occurred. What this means is that if we know event B occurs, what's the probability of event A also occurs? And we write this as P of A line B, and you read this as probability of A given B, meaning that event B already occurred. Let's find the probability that A also occurs. So For each one of these, so we learned how to calculate simple probability. So if I have probability of A and B, I use what's called the general multiplication rule. So P of A and B, this is P of A times P of B given A, or probability of B times probability of A given B. And we'll see in a second how to calculate this probability, but this is called the general multiplication rule. What I want you guys to think about is what happens to this general multiplication rule if the events are independent. So by the time we're in class, hopefully you'll have an idea of what will happen if these events are independent, and you can bring it to class. So next one is the general addition rule. So general addition rule, this is for or. So if I see A or B, I do P of A plus P of B minus P of A and B. So probability of A plus probability of B minus probability of both occurring simultaneously. And we'll use a two-way table to show why this makes sense. But I want you to also think about if these events are mutually exclusive, what's going to happen to this general addition rule. So then the last one, so we saw this as part of the general multiplication rule. Conditional probability, probability of A given B is equal to probability of A and B over the probability of just B. And so if this had been the other way around, B given A, you would just switch the A and B in here. This would be probability of A right here. But this is the general formula. So what I want you to think about with this formula is I want you to think about what happens if these events are independent. And I also want you to think about what happens if these events are mutually exclusive. So I'm going to give you some time before class to think about that. So those are our formulas. Now, this page right here, we're going to summarize all of this in class, but what I want you guys to do is I want you to pause on this page and take down whatever notes you need. This last event is just about mutually exclusive, so you might not need to write this down if you understand what mutually exclusive means. But these ones up at the top, these first two are really important to remember. Remember, the probability is a number between 0 and 1. Probability of 0 means that it can never possibly happen. Probability of 1 means that it will always happen. If I have all of the possible outcomes for any sample space, all of their probabilities must add up to 1. Same thing with, if you think about well, actually, we'll talk about percentages later. Percentages are a form of probability. It's just, so if you have like 78%, that would be a probability of 0.78. You guys know how to write back and forth between percentages and decimals. But probability is expressed as a decimal between 0 and 1. And then we've already talked about how to calculate this. A complement. The complement is the opposite of an event happening. So AC, so this A with the C as a superscript, what this means is not event A. So not event A happening. And then down here, mutually exclusive, we've kind of already talked about. So again, you can pause this, take any notes you need to off this page. We're going to keep rocking and rolling. And this is going to lead into some practice. I'll leave each of these up here for just a second so you can pause if you want to, but we're going to do these in class. All right, so we will come back to that. Same thing with this. This is some practice that we'll do in class. If you want to, you can go ahead and start practicing some of this on your own. And more practice. We'll do this in class again, but I want you to go ahead and see it so you can try it on your own if you want to. So that is it for today. Today we talked about the basics of probability, what it means for events to be independent or mutually exclusive, and then the probability rules. So I hope you took some good notes, and I will see you in class. Have a fantastic day.